Okay, for this practical we're going to be measuring the acceleration due to gravity using experiments that Galileo first set up with inclined planes and with pendulums. So you probably don't have an inclined plane hanging around, so I've come to my parents' house to use this very nice kitchen table, nice smooth surface down which we're going to roll those balls. And the main thing to remember in all of this is, as it says behind me, don't panic. Right. So the first thing we've got to do is elevate the plane to get an angle on it so that the balls can roll down under the force of gravity. So, handy dandy cooking books, get my coffee off the table, and we're going to elevate the plane. So there you go. You don't need to do this to a great degree. There you go. We just lifted it slightly on one end. So this is about a 1.5 meter, 2 meter table. And I'm going to measure how much that lift is off the ground. So tape measure and measure the elevation of it off the ground. And so for me on this experiment, that's about 40 millimeters, 4 centimeters on there. And that's going to be in the equations, in the spreadsheets that you're working with. That's the distance h, okay, the angle of that plane. So the next thing we need to do is measure the actual distance that the ball is going to roll down the plane. And so I'm going to set my tape measure out here, and we're going to be measuring this distance down this inclined plane. So I say to do this experiment with either solid balls or a hollow cylinder. Now, if you've been in the class, we'll be able to provide those hollow cylinders. I've got a couple of balls here. A golf ball will do. This one is just a big solid rubber ball. It's another sort of solid ball on here. And the equations that are provided for you actually are for the solid balls, for hollow cylinders. And so you've got to use the appropriate equation for the appropriate object we're going to roll down the plane. Okay, so the first part of this experiment is measuring different times for the ball to roll down different distances down this slope here. So my slope, I'm going to take it as 1.50 meter long to here. I'm actually going to do about 6 different measurements. I'm going to start at 50 centimeters, so that's here, and I'm going to start by holding the ball here and then releasing it so it rolls down to the end. When it drops off the end, I'll stop my clock at that point. Now, most of you, I'm quite sure, have got mobile phones with stopwatches on it. They're pretty standard parts of most mobile phones these days, even if you don't have a truly smartphone. Get the clock up on it, and you'll see in most of your clocks that you've also got a stopwatch. Now, these stopwatches on here are incredibly accurate devices. Unlike what Galileo had, of course, he had to invent the water clock before he could do his experiments. So we've got an ability that he didn't have to measure very, very precisely the times of the ball rolling. And actually, on my particular stopwatch, it can measure it to 0.01 of a second. Now, clearly, the accuracy that's built into the stopwatch here is way beyond that which we can measure or repeat our measurements, in particular on this experiment. So rather than just relying on one measurement for one distance, you're going to do it a number of times. So for instance here, at 0.5 meter down, I will start my stopwatch when I start the ball rolling and stop it when it rolls off the end, and then I'll repeat that 4 times, and we'll get an average then of the time it takes to go from this position here to the end. So here we go, 3, 2, 1, start, stop. And for that first measurement, I've got 2.17 seconds. So that's what I enter then into the spreadsheet for the 50 centimeter distance. I'm going to repeat that now another 3 times for the short distance. Then I'm going to move to 75 centimeters and measure that. Then I'm going to move to 1 meter, measure that, and therefore fill out the elements on the spreadsheet that you've been provided. Okay, so once you've got your data, then what you need to do is enter it into the Excel spreadsheet for part A. So for instance, on the blank spreadsheet in here,
the height I lifted my table here, kitchen table, was 1 centimeter. I calculated using Pythagoras there that the angle that was for the length of table I had was 0.29 degrees. That goes in there. And then the distance that the ball was rolling down the slope. So in this particular first experiment, I measured it along the length of the slope. So that's was 200 centimeters. And then the times I measured, so here we go. The first time I measured was 12.1 seconds. And then the second time was 13.2. And we go 12.5. And we've got 12.8 as the last one. And with those entered in, you'll see that the spreadsheet has automatically calculated an average time for this and the time squared. So this is obviously what Galileo was the real revolution in what he was doing, was that it was proportional to the square of the time. So you'll also note that as I was doing that, the trend line was, the data was starting to populate in the graph below. So here again, the distance on the here on this vertical axis, 200 centimeters, and on the horizontal axis, you've got the average time that's coming up in there. So do this for all of the rest of the distances that you've measured for different angles, or sorry, for this experiment for the same angle. And you can see in here I've done that. Different distances being rolled down the plane and different times in here. It gives us an average, and you'll see that it plots a particular slope curve. It's a straight line curve in this case, and the equation for that ends up by giving us our mean of the gravitational acceleration, which for my experiment worked out 9.84 meters per second squared. It also, this little spreadsheet in here actually gives us a few other important things to look at, and particularly in terms of looking at the error within the data sets in here. So we're looking at standard deviation to then get us the error from our calculations. So that'll be the end of the part A of the experiment.
Okay, for the second part, part B in here, we're going to use that same Excel spreadsheet to enter data, but this time instead of varying the length along which the ball measures, we're going to vary the angle of the slope. So you've measured it once with the angle that we set to start with, run the experiment again for that, and then change the angle. And so here we go, I have to run my experiment on that, another book, and another angle. We'll repeat the experiment then with the second angle. So try and do that for a number of different angles. Don't go too wild. You don't need to sort of jack this up until it's sort of hanging in the middle of the air, or whatever. It's the angular change can be a few degrees and the equations will still work out. So repeat the experiment, change the angle, enter the data into the spreadsheet.
Part B of the experiment, where you're going to change the angle. So again, in here we've got the height, change in height that we are lifting the slope up against, and working out the change in the degrees, the angle of the slope. The distance we're rolling down, we're going to keep the same, and then again we're going to do the experiment 4 times over, so we get an average. And here again, one that we did earlier, I can see that I've actually put in here differences in terms of I changed the angle of the slope, or the direction of the angle of the slope, so I'm putting in negatives in here. It's important that you would do that if this is how you are running your experiment. But you don't necessarily need to do that. You could just do it different positive in the singular directions in there. Okay, so again, this will automatically populate the average time and the acceleration in here, the angles, and so we end up with an acceleration due to gravity, in my case 9.8 meters per second. Okay, so meters per second squared, sorry. So use these spreadsheets and fill out the data in them, and then we can calculate the acceleration due to gravity from these very simple experiments. Very simple experiments, but actually very close to what we know as gravitational acceleration today. So even though they're very simple experiments, it is quite remarkable how well that they have actually reproduced a decent number for our acceleration due to gravity. So well done, Galileo. Got it right all those hundreds of years ago. What a genius.
So the next experiment we're going to do is copying what Galileo did with pendulums, and in fact this was probably more important in terms of his discoveries than actually rolling balls down slopes. And of course we've got that great example from the Duma in Pisa of the big chandelier that goes back and forwards and oscillates. So again, he didn't have a clock. We're going to use your stopwatch on your mobile phones, and we're going to create a pendulum with a piece of string and some heavy object. So I've got a bunch of car keys here, and the first thing that we're going to do is measure a pendulum length. And so I'm going to start with a pendulum that's not too unwieldy here. Let me see, I'll measure off perhaps a 1.5 meter pendulum. So there's 1.5 meters of string measured there. And we're going to then tie the keys on at that point on the actual string. So simple set experiment set up. Get the pendulum tied on, and we're going to then measure the number of seconds, or the time it takes for the pendulum to swing through a single period. In other words, one oscillation. So one oscillation is from one side of where you let the pendulum go to the other side and back again. Now what you'll find if you do that and you start your stopwatch is that it's quite hard to know exactly when it stops and starts. Okay, and so a more accurate way of working out what the time is for one oscillation is to actually measure the time over a number of oscillations, say 5 or 10 oscillations. So I'm going to do this. You need multiple hands, so maybe a friend can help you. You're just going to start your stopwatch as the pendulum, as you let go of it. So here's 3, 2, 1, start. And then you're going to time this for 5 swings. Want more accuracy, you can time it for 10 swings. Back and forwards 10 times, and of course then to get the average of the time, it's then divided by the number of swings that you get. So enter that into the equations given in the spreadsheet. This doesn't have an Excel sheet to work with. You're just going to do hand calculations on this on the spreadsheet that I've given you in terms of the worksheet, and you're going to measure different lengths of pendulum and time different number of oscillations, and from that then we should be able to work out what this acceleration is due to gravity. So a very, very simple experiment. Measure the length of the pendulum, different lengths of pendulums. I wouldn't go over the top about this. Don't try and do it from the top of your stairs with a 20-meter long pendulum. That's if any of you have a 20-meter high staircase. 1 meter to 2 meters in terms of the length of the string, the length of the pendulum is more than adequate to be able to do this experiment. Okay.